Hello everyone, welcome for this lecture. Today we are going to solve the numericals on difference equations. Okay, so in the previous classes we have studied the difference equation. Generally, it's a general equation, and what are the solutions of that, and how to calculate the natural response of that and forced response. Today we are going to calculate, means we are going to find some total responses. Okay, where in this we are supposed to calculate the natural response as well as the forced response. Okay, so let's take an example of this. First example, evaluate a natural response, forced response and a total response for a system described by the following difference equation. That difference equation is given by y of n plus y 0.1 y of n minus 1 minus 0.3 y of n minus 2 equal to 2 u of n. So y of minus 1 equal to 0 and y of minus 2 is equal to 0. So they have given a initial conditions of that y of minus 1 and y of minus 2. So remember, when you are finding out the total response, so as we know, that is the total response, that is y of n will be equal to yn of n plus yf of n. So this is the natural response plus forced response. Okay, and so let's find out the first natural response of this, and then we'll find out the forced response of this. Okay, a slight change will be there when you are finding out the total response. Okay, so what we have to do is, let's take this equation, general equation, and from that we have to identify the roots to calculate a natural response. Okay, and then we have to identify based on the roots how those roots are, and then based on those roots we have to identify its structure. Okay, let's take, this is your y of n plus y 0.1 y of n minus 1 minus 0.3 y of n minus 2 equal to 2 u of n. Now let's get the characteristic equation of this equation, that is by taking by substituting y of n minus 1 as z inverse. Okay, let's take, if this is so, then y of n will be 1 plus 0.1 into z inverse minus 0.3, that is y of n minus 2 is nothing but z raised to minus 2 equal to 0. Okay, so this is our characteristic equation. Once we have got this characteristic equation, you can solve this by taking multiplying z square on both the sides of this equation, because we have inverse, we are not so comfortable with that, so we'll convert that into a z. Okay, to get that we have to multiply this entire equation by z square. If you multiply so, then it will be z square plus 0.1z minus 0.3 equal to 0. This is your actual characteristic equation. So solve this. By solving, you will get z1 equal to 0.5 and z2 equal to minus 0.6. Take a quadratic equation and then solve this. Okay, it will be 0.5 and minus 0.6. So now roots are real and distinct. Okay, so then roots are not repeated, and here in this 2u of n, so there are no roots, this will not be dependent on this input. So based on this characteristic equation, these roots are real and distinct. So when roots are real and distinct, natural response structure will be c1 r1 raised to n plus c2 r2 raised to n. Just go through this structure of natural responses. Okay, now yn of n will be equal to c1. So constant we are supposed to calculate. R1 is 0.5 raised to n plus c2, r2 is minus 0.6. So substitute in this, minus 0.6 raised to n. Okay, this is your natural response. Keep aside. Now don't go for calculation of c1 and c2. Okay, this is a slight change what I said. So when we have a natural response, that time c1 0.5 raised to n plus c2 minus 0.6 raised to n. Don't go for calculation of this by taking its initial condition. This initial conditions is based on the total response. Okay, this is a slight change in this. Okay, when you are finding out the natural response directly, we would have substituted these values, but now this will be when they have asked us the total responses. These initial conditions are for total responses, not for individuals. Okay, so then keep this aside, your natural response, and then next thing is to calculate the forced response. To calculate the forced response, it is totally dependent on the input, what it is. Input is to u of n, means on u of n is your input. U of n is a constant. Okay, therefore what about the structure of a forced response? It will be, forced response will be one constant. Okay, yes, next thing what we have to do is observe this general equation, that is y of n minus 1 and minus 2. You have got y of n, that is c. Now we have to change that this equation to a n minus 1 and n minus 2. Okay, then substitute these values in this equation. Okay, and compare the coefficients, and then you will get a constant c value. C1 and C2 are constant for natural response. C is for your forced response. Now we'll take y of n equal to c, then change the n to n minus 1. When you change n to n minus 1, on the right hand side we have only c, so it remains same. Even y of n minus 2 also c, so only these three we require. Substitute these values in the given general equation, that is this equation, y of n plus 0.1 y of n minus 1 minus 0.3 y of n minus 2 equal to 2 u of n. Substitute y of n is c, and then y of n minus 1 is also c, and n minus 2 is also c, so it is plus 0.1 c minus 0.3 c equal to 2. Then simplify this. 1 plus 0.1 is 1.1 minus 0.3 is a 0.8, c equal to 2. Then c equal to 2 by 0.8, you can simplify it, you will get a c is equal to 2.5. Yes, forced response will be equal to 2.5. Then what will be the total response of this? Total response, you can take it as yt also. Yt of n means total response of that difference equation will be equal to natural response plus forced response. So then what we have to do is get that yt of n equal to, this is your natural response and this is your forced response. After substituting this value, we have to go for this, that is initial conditions what they have mentioned. These initial conditions they have mentioned based on your total response, that is y of minus 1 equal to 0 and y of minus 2 equal to 0, right? Y of minus 1 means n equal to minus 1. In the place of n we have to substitute minus 1. Okay, now so let's take in this equation substitute y of minus 1, which is equal to c1.1 raised to minus 1, okay, plus c2 minus 0.6 raised to minus 1 plus 2.5. Y of minus 1 is 0 equal to c1 divided by 0.5. Okay, as I told you, 0.5 raised to minus 1 is nothing but 1 divided by 0.5. Okay, so in this equation if you write c1 by 0.5, c2 divided by minus 0.6, so this minus and I can place here, plus 2.5 equal to 0. Simplify this equation, you get a one equation, that is 2c1 minus 1.66 c2 equal to minus 2.5. Let's call this equation number 1. Next, so we'll take another initial condition, that is y of minus 2, okay, where n is equal to minus 2. Let's substitute in this equation, that is c1.5 raised to minus 2 plus c2 into minus 0.6 raised to minus 2 plus 2.5. So simplify this, y of minus 2 is 0, c1 divided by 0.5 square plus c2 divided by minus 0.6 square plus 2.5. So minus 0.6 square minus positive plus, so 0.6 square we have to calculate. So by simplifying this also we get another equation, which is 4c1 plus 2.77c2 equal to minus 2.5. by solving these two equations, that is 2c1 minus 1.667, c2 minus 2.5, and this equation 4c1 plus 2.77 c2 equal to minus 2.5. By solving these two, we get an equation, that is we get the roots of that equation, that is c1 equal to minus 0.909 and c2 equal to 0.409. Therefore, your total response, we can write y2 of n will be equal to c1 into 0.5 raised to n plus c2 minus 0.6 raised to n plus forced response, which is 2.5. This is how we have to calculate the total response of the difference equation. Okay. Similarly, we'll see one more equation, means one more numerical. So we'll easily deal with this. Okay. They have asked to find the solution of a difference equation given below by using prescribed initial conditions. Y of n minus 0.6, y of n minus 1, which is equal to x of n. That x of n is the input. They have mentioned x of n is equal to 0.4 raised to n, that is alpha raised to n. Remember, n is greater than or equal to 0. Okay. Now, what we have to identify is, they have not specified, just they have said find the solution of a difference equation, but they have not specified is that natural or forced. So then what we have to do is, we have to calculate the total response of that, yt of n. I hope you be careful about yt, and this is yt of n. Okay, this is the total response. Total response of a continuous signal can be taken yt of t, capital T of small t. Okay. So now, take a general equation and then get a characteristic equation of that. So which is y of n minus 0.6, y of n minus 1 equal to 0 we can take. And then substitute y of n minus 1 as z raised to minus 1. Okay. Then this equation, characteristic equation will be 1 minus 0.6 z raised to minus 1 equal to 0. Get that in the simplified manner by multiplying z for this entire equation, that is z minus 0.6 equal to 0, where z equal to 0.6. This is a single root, so we have z equal to 0.6. And then natural response is what? One root we have, and that root also real and distinct. Therefore, it is c1 into r raised to n. Therefore, yn of n will be equal to your c1 into r is a root. So 0.6 raised to n. Let's call this equation number as 1 right now. Okay, because this is a natural response. And then we'll find out the forced response, that is by taking the input. What is the input? Input is 0.4 raised to n, which is nothing but your alpha raised to n. Okay. Now, roots are not repeated. Meaning of this one is this alpha, this alpha and this z are not repeated. This is a root and this is also one root. So those two are not repeated. So what we can take is forced response will be equal to c1 into 0.4 raised to n. So now, from forced response to calculate this, once we have got y of n, then we have to take y of n minus 1. Okay, that's enough, because only one more parameter is there. So just substitute yf of n equal to c1.4 raised to n. In that place, change the n to n minus 1. So when you are changing n to n minus 1, then it will be c1.4 raised to n minus 1. Okay, we are changing n to n minus 1. Here it should be n minus 1. So simplify this, it will be c1 as it is, 0.4 raised to n it is, and into 0.4 raised to minus 1. Okay, when we have 0.4 raised to minus 1 is nothing but 1 divided by 0.4. Therefore, easily we can write y of n minus 1 will be c1 0.4 raised to n divided by 0.4. And then from the main equation, that is y of n minus 0.6, y of n minus 1 equal to x of n. So substitute these values, that is y of n as this equation, n minus 1 as this equation, and compare the coefficients. Okay, yes, y of n is c1.4 raised to n minus 0.6 as it is, y of n minus 1 was how much? It is c1, this value. Okay, it is c1 0.4 raised to n divided by 0.4. Okay, equal to 0.4 raised to n. So now let's simplify this. It is a c1.4 raised to n as it is, minus 0.6 divided by 0.4 we can take aside. Okay, one side you can keep, minus 0.6 divided by 0.4, c1 into 0.4 raised to n equal to 0.4 raised to n. Now we can compare the coefficient of 0.4 raised to n, that is it's 0.4 raised to 0.4 raised to n's coefficient is c1, and in this side 0.4 raised to n coefficient is minus 0.6 by 0.4 into c1, which is equal to its coefficient is 1. Okay, now take a c1 outside. When you take c1 outside, 1 minus 0.6 divided by 0.4 is nothing but 1.5, which is equal to 1. So 1 minus 1.5 will be minus 0.5, then 1 divided by minus 0.5 will be your minus 2. It's a forced response. This is what your forced response coefficient. Therefore, please don't get confused with the C1 of a forced response and C1 of your natural response. Okay, both are different. For if you are getting confused, you can take this as C1n or Cn1. Okay, natural response coefficient 1, constant 1, and this you can take it as a CF1, forced response constant. Okay, and once we got those values, substitute in the forced response, that is y of n equal to c1 into 0.4 raised to n was there. C1 is minus 2, so substitute its value, minus 2 into 0.4 raised to n. Then total response is, okay, yt of n will be equal to yn of n plus y of n. So now yt of n equal to, what was that natural response equation? Which one? That is yn of n equal to c1.6 raised to n. Therefore you substitute that one, which is c1.6 raised to n minus yf of this, that is minus 2.4 raised to n. Now take initial conditions. They have said that y of minus 1 equal to 10. Substitute that equation here. Okay, y of this is your total response. Now in this you can substitute y of minus 1, wherein we have that place minus 1. Then it is c1.6 raised to minus 1 minus 2 into 0.4 raised to minus 1, where 0.6 raised to minus 1 is nothing but 1 divided by 0.6, minus 2 into 0.4 raised to minus 1 is nothing but 1 divided by 0.4. Simplify this, whereas y of minus 1 is how much? It is 10. 10 equal to, so simplify this, 0.6, 1 by 0.6 is nothing but 5 by 3 and minus 5. So therefore C1 will be equal to this 5, you send this side. Okay, simplify this equation. So C1 5 by 3 equal to, you can do, then this 5 you can send this side, which is equal to 15. Therefore C1 will be equal to 15 into 3 divided by 5. So 5 3s are, so 3 3s are 9. Therefore C1 of this C1 is of natural response constant, which is 9. Okay, 9.6 raised to n minus 2.4 raised to n. So this is your total response of the given equation. Okay, so only one thing which we are going to concentrate on this is, whenever they ask you to calculate the total response, please remember that we are not supposed to go for natural response directly. Once we calculate natural response structure, don't go for calculation of its constant. Okay, first get forced response also, and then add those two, then your total, this will be your total response, and then we have to find out after that we have to apply initial conditions.